What is Taproot? Taproot is a Bitcoin protocol upgrade designed to improve the efficiency, privacy, and functionality of transactions. It builds upon previous upgrades like segregated witness, or popularly called as SegWit, which separated transaction signature from transaction data to increase block capacity and ensure new features. Taproot introduces three key innovations: BIP 340, a new digital signature scheme that replaces the older epileptic curve digital signature algorithm for certain transactions. Schnacknor signature are more efficient and enable advanced features like signature aggregation. The second one is Taproot BIP 341, a new transaction output type that enhances privacy and flexibility by combining complex spending conditions like multi-signature or time locks into single compact format. TapScript BIP 342, an upgraded scripting language that provides more flexibility for defining custom transaction conditions while maintaining compatibility with Bitcoin's existing scripting system. Together, these changes make Bitcoin transactions more private, cheaper, and capable of supporting complex smart contracts without clogging the blockchain or revealing unnecessary details. So, why was Taproot needed? Bitcoin's original design prioritized security and decentralization, but it faced challenges in scalability, privacy, and smart contract functionality. For example, Bitcoin's 1 MB block size limits the number of transactions processed per block, leading to high fees during network congestion. Bitcoin transactions are pseudonymous, not anonymous. Complex transactions like multisig setups reveal a structure on chain, potentially exposing sensitive details. Bitcoin scripting language is intentionally simple to minimize vulnerabilities, but this restricts its ability to support sophisticated smart contracts compared to platforms like Ethereum. Taproot addresses these issues by making transactions more efficient, hiding complex conditions, and enabling new use cases, all while preserving Bitcoin's core principles of security and decentralization. Now let's look at the core components of Taproot. Let's break down the three BIPs that form Taproot and how they work together. Schnorr signatures, or BIP 340. Schnorr signatures are random cryptographic signature schemes that with several advantages over ECDSA. Efficiency. Schnorr signatures are smaller in size and faster to verify, reducing the computational burden on Bitcoin nodes. Linearity. Schnorr signatures support signature aggregation, meaning multiple signatures can be combined into single signature. For example, in a multisig transaction requiring 3 out of 5 signatures, Schnorr allows all signatures to be compressed into one, reducing transaction size and fees. Aggregated signatures make multisig transaction look identical to standard single signature transaction on the blockchain, enhancing user privacy. Schnorr signature also enables advanced cryptographic techniques such as threshold signatures, where a group of signatures can collaboratively sign a transaction without revealing individual contributions. Now let's look at the second one, Taproot, BIP 341. A Taproot upgrade introduces a new output type called Pay to Taproot, P2TR, which combines two spending paths. Key-based spending. A transaction can be spent using a single public key and its corresponding Schnorr signature, similar to standard Bitcoin transactions. Script-based spending. Alternatively, the transactions can be spent by satisfying a set of conditions defined in MAST. MAST is key innovation in Taproot. It recognizes complex spending conditions, for example, multisig, time locks, and other scripts into tree structure, where only the specific condition used to spend the transaction is revealed on chain. This has several benefits. Privacy. Unspent transactions remain hidden, so outsiders cannot see the full set of rules governing the transactions. By revealing only necessary script, master reduces the data stored on the blockchain, lowering transaction fees. Flexibility. MAS supports a wide variety of spending conditions, enabling complex smart contracts without compromising efficiency. For example, imagine a multi-sig wallet requiring 2 out of 3 signature, or a time lock allowing funds to be reclaimed after 30 days. With Taproot, this setup appears as a single public key on chain. Only when the funds uh, are spent is a relevant script revealed, and the time lock condition remains private. TapScript BIP 342. TapScript is a evolution of Bitcoin scripting language designed to work with Taproot P2TR outputs. It introduces new opcodes, that is operations, and removes certain restrictions from the original scripting system, making it easier to define custom transaction conditions. For example, key features include um, tra- transcript op- trans- TapScript optimizes how scripts are processed, reducing the computational overhead for nodes. By removing limits like the maximum script size, TapScript ensures Bitcoin can support new features without requiring additional upgrades. TapScript works seamlessly with Schnorr signature and MAST, enabling developers to build sophisticated applications on Bitcoin. Now let's look at how Taproot works in practice. To understand Taproot's impact, consider a practical example, a Lightning Network channel. The Lightning Network is Bitcoin's layer 2 scaling solution, allowing users to transact off-chain while settling periodically on the Bitcoin blockchain. A Lightning channel involves complex scripts, multisig, to ensure security. Now let's look what happened before Taproot. Opening or closing a Lightning channel requires a transaction that revealed its multisig and time lock conditions, making it indistinguishable from the regular transactions. These transactions were larger, increasing fees and consuming block space. The public nature of scripts reduced privacy for channel practices. With Taproot, the channel's funding transaction uses P2TR output, appearing as a single public key on chain. When closing the chain, only the relevant spending conditions is revealed, while other conditions remain hidden. The transaction is small, cheaper, and indistinguishable from standard Bitcoin transaction, boosting both privacy and scalability. This example illustrates Taproot's ability to make complex transactions efficient and private, which is especially valuable for layer 2 solutions like Lightning. Now let's look at the benefits of Taproot. Taproot brings several advantages to Bitcoin users, developers, and network as a whole. By hiding unused spending conditions, Taproot makes complex transactions look like regular transactions, reducing the ability to analyze wallet structures. This uniformity strengthens Bitcoin's fungibility, as all transactions appear similar regardless of their complexity. Schnorr signatures aggregate and mass reduce transaction sizes, lowering fees, especially for multisig and smart contract transactions. Smaller transactions free up block space, benefiting all users during periods of high network demand. By optimizing transaction data, Taproot allows more transactions to fit in each block, complementing SegWit's earlier scalability gains. This efficiency supports layer 2 solutions like Lightning, which rely on compact on-chain transactions. Taproot's MAST and TapScript enable developers to create more sophisticated smart contracts, such as escrow services, decentralized finance protocols, or even non-financial applications. These contracts are private and efficient, making Bitcoin a more viable platform for programmable money. TapScript's design allows for new opcodes and features without requiring disruptive protocol changes, ensuring Bitcoin can evolve over time. Now let's look at the implications for Bitcoin's ecosystem. Taproot's activation has far-reaching effects across various aspects for Bitcoin. Individual benefits from lower fees and improved privacy, especially when using wallets that support the P2TR outputs. Taproot compatible wallets like Bitcoin Core or certain hardware wallets allow users to leverage these features. Taproot opens new possibilities for building applications on Bitcoin, from advanced Lightning network implications to novel smart contracts. However, developers must update their software to support Schnorr signature and TapScript. Taproot is a soft fork, meaning it's backward compatible. Non-upgraded nodes can still validate Taproot transactions, but only upgrade nodes can fully verify Schnorr signature and P2TR outputs. The Lightning Network and other scaling solutions gain significant efficiency and privacy boost, potentially driving broader adoptions of off-chain transactions. Taproot's ability to obscure transactions details signs with the growing demand for financial privacy, though Bitcoin remains pseudonymous rather than fully anonymous. Now let's look at the challenges and limitations. While Taproot is a major step forward, it's not without its challenges. For Taproot to reach its full potential, wallets, exchanges, and other services must implement support for P2TR outputs and Schnorr signatures. As of 2025, adoption is growing but not universal. Developers need to understand Taproot's new features like MAST and TapScript to build compatible applications. While Taproot improves privacy, it doesn't make Bitcoin fully anonymous. Users must still practice good privacy habits like avoiding address reuse. Taproot enhances efficiency but doesn't dramatically increase Bitcoin's base layer transaction throughput. Scalability still relies heavily on layer 2 solutions. Taproot builds on earlier upgrades like SegWit, which happened in 2017, which fixed transaction malleability and increased block capacity, and the BIP32 and BIP44 standards for hierarchical deterministic wallets. It also sets the stage for future implementations, such as cross-input signature aggregation, which could further reduce transaction sizes by aggregating signature across multiple inputs. Compared to other blockchains, Taproot positions Bitcoin as a more private and flexible platform without sacrificing its minimalistic, security-focused design.
While Ethereum excels in general purpose smart contracts, Taproot makes Bitcoin competitive in specific use cases like financial contracts and layer 2 scaling. Taproot is a transformative upgrade that enhances Bitcoin's privacy, efficiency, and programmability. By introducing Schnorr signatures, MAST, and TapScript, this streamlines complex transactions, reduces cost, and enables new possibilities for smart contracts and layer 2 solutions. While adoption is still progressive, Taproot's benefits are already evident in applications like Lightning Network and privacy focused wallets. For Bitcoin to remain a leading cryptocurrency, it must balance innovation with its core values of decentralization and security. Taproot achieves this by delivering meaningful improvements without compromising the protocol's robustness. As developers and users continue to embrace Taproot, it will likely play a central role in Bitcoin's future, reinforcing its position as a cornerstone of decentralized economy.